Today's lesson is about simplified radicals. Assume all variables are positive real numbers. For part 1, you could see this is all square root, and there's no variables, only numbers. So let's get started from some simple number square. We do 2 square, that's equals to 4. 3 square equals 9. Then 5 square equals 25. 7 square equals 49. I need to remember this 4, 9, 25, or 49. These 4 numbers normally we used as a factor to simplify radicals. Because square root of 4, you will get 2. Square root of 9, you will get 3. Square root of 25, you will get 5. Square root of 49, you will get 7. The next number you used as a factor will be square root 121 equals 11. Normally, as long as you can remember this 4, 9, 25, 49, that's good enough. We call this 4, 9, 25, 49 and as a perfect number. Whenever any number, square, we call this is a perfect number. You got to use those perfect number as factors so that you can simplify square root. For example, like number 1, square root of 75. You will see 75, can we divide it by 4? No. Can we divide by 9? No. Can we divide by 25? Yes, I will do square root of 25 times 3. For square root of 25, you will get a 5 outside. That's how you get the 5. Square root of 3 will be the simplified radicals for number 1. For number 2, 5 square root of 48. If you do know that 16 is a perfect square number, and 16 times 3, it's 48. You can take 16 out as 4. Multiply by this 5, you will get 20 square root of 3. Or you can do this way, 48. You will see, okay, square root 48, can we divide by 4? Yes. 48, I can divide it by 4. I will get 12. 12, you can keep divided by 4. Using those 4, 9, 25, 49 as a perfect square number. Then here's a 4, here's a 3. So you can get the 4 times 4 times 3. As long as the last number is not the perfect square as a factor, then you stop. So you will get the 5 times. 4 you take out, that's a 2. This 4 take out is 2, then square root of 3. So you will get 20 square root of 3, the same answer. So either way will be fine for simplified radicals. For number 3, 120, you will see the 120, we can divide it by 4. You will get 30. Then you got to use this 4, 9, 25, 49 to check this 30. 30 cannot be divided by 4, 9, 25, 49. That's the reason this 30 you state you cannot simplify further. So you will get a negative 2 times square root 4 times 30. Then you take square root of 4, that's 2 out. Negative 2 you state negative 2 times 2 square root of 30. So your final simplified radical will be Negative 4 square root of 30. Let's go to number 4. Negative 9 square root of 60. For this 60, can I do 2 times 30? It's not a good way to do that, 2 times 30, because for 2 and 30, both cannot be divided by perfect square number, like 4, 9, 25, 49. So you always use a perfect square number 4, 9, 25, 49 as your factor. So for this 60, can we divide it by 4? Yes, it's 15. 15, can we divide by 4, 9, 25, 49? No. So we keep that 15 in that square root. So you will get a negative 9 times square root 4 times 15. Take this 4 out, you will get 2. So negative 9 times 2 square root of 15. So the final answer will be negative 18 square root of 15. Let's go to part 2. This time for square root, we have variables. So how to deal with the variables? First of all, you know that the roots over here, that is 2. You know, here's 2 for the square root. So you got to use the exponents in this square root divided by 2. For example, I have 3, right? So 3 divided by 2. You change into mixed fraction. If you cannot get a mixed fraction, then it's you stay. 3 over 2, I can write down 1 plus 1/2. We do know that radical exponents, we know a to the m over nth power. That means nth root of a to the mth power. Therefore, for x, we do the 3 over second power. I can write down x is 1 plus 1/2. We do know the power rule is a to the mth power times a to the nth power. That equals am plus n. So we do the backwards this time. For this one, you will get x to the first power times x to the 1/2 power. X to the 1/2 power, we know that is a square root of x. So for x is a 3 over second power, you can simplify as this. In other words, when you have rational exponents for these integers, you will write down that x to this power times 1/2 power. That means square root of x. Now let's go back to number 5. Square root of 50, remember, use the perfect square number as a factor, 4, 9, 25, or 49. Therefore, for 50, I can do 25 times 2. For x to the third power, we already know that it's x square root of x. For this 6 divided by 2, that is 3, which means it will be y to the third power. And look at the z, that's 7 over 2. I can change it into mixed fraction, that is 3 plus 1/2. Because 7 divided by 2 is 3. That's how you get the 3 plus 1/2. So that you can get z to the third power from here. Then 1/2 power will be square root of z. For 25, you will get the 5 outside. So I will get the 5. Then outside number will be this x, will be this y to the third power. this z to the third power. Then what's in the square root? You will get 2. Here's x. Here is z. This will be the final simplified radicals. Okay, let's go to number 6. You will have a -3 state. Square root of 24, you can write down 4 times 6. Don't write down 2 times 12 because both 2 and 12, they are not perfect square number. Then I multiply by, look at the x to the 4th power. 4 divided by 2, that's 2. So you will get the x squared. Look at the y. Y is 9 over 2. So you will get the 4 plus 1/2. This 4 will be exponents. So y to the 5th power square root of y. 1/2 power means square root. Look at the z. 5 over 2. That is 2 plus 1/2. So you will get the z squared, square root of z. Then you will put the outside number together. This square root of 4, that's 2. So -3 times 2 outside, square root of 6. Now let's check outside number. I have -6. I have x squared, y to the 5th power, and z squared. Then what's inside this square root? I have 6. I have this y. I have this z. So this will be the simplified radicals to number 6.